Good morning. My name is Carsten Friberg. I'm the Executive Director of IPHA. I would like to welcome all to this IPHA webinar. It's the 5th webinar in our series of monthly webinars. In the webinars, we invite 3 of our member companies to present a company webinar at 15 to 20 minutes duration, showing innovations and developments which could be of interest to our members. In this 5th webinar, I'm very happy to welcome Sika from Switzerland, Spiroll from United Kingdom, and Blij from the Netherlands. I hope that you will find it interesting and useful to see the presentations which now follow. And I will leave it to IPHA's webmaster, Tom Goosey, to conduct this event. Thank you very much.
Thank you, Carsten. Good morning, everybody. Thanks for joining us. Just a couple of quick things from me, really. Some of you have probably joined us before, but for those who haven't, thank you for registering and watching this morning. So before I introduce our first speaker, just a reminder that each presentation will be roughly 20 minutes, but we're hoping that at the end of each one you may have a couple of minutes for questions. So if you do have any questions, on the right hand side you'll see a questions tab on your control panel. You can type them into there and I can relay these to the presenter if we have time at the end of each presentation. And then also you know, if there's anything that you think will be useful for colleagues who aren't able to attend today, just a reminder also that I will post these on the IPHA website after the event as a recording, and we'll put out a notice when those are available. So yeah, that just leaves me to hand over to our first presenter, who is Dr. Markus Mueller. Markus is Marketing Development Manager at Sika, and Markus is going to talk to you about admixture solutions, systems and concepts for precast concrete. He's going to show you how to increase productivity and cope with challenges of today and the future. So let me pass over to you, Markus. There you go. It's all yours.
Thank you very much, Thomas. Let me share with you my slides. Can you see my presentation now?
Yes, we can, Markus.
Excellent. So hello again, everyone. And thanks to Thomas and for the technical support, and to Carsten Friberg for giving us this opportunity to introduce ourselves and at least have some kind of interaction in these socially challenging times. So as it was introduced, I'd like to provide you our efficient and sustainable solutions for precast concrete production in a short presentation. First, to all of you who don't know Sika yet, we are a construction chemicals company. So we are providing chemical additive and admixture solutions to concrete producers, to many other producers and industries. Around 25,000 people work for Sika today in 100 countries. So on every continent you find Sika. And even if our products may not be visible all the time, since there is no Sika logo on the final end product, they actually are quite widely used and distributed. For example, about every second car drives with some Sika products inside. So which markets are we working on? You see, first of all, here concrete, but also many others: waterproofing, roofing, building finishing, flooring and coating, sealing and bonding, refurbishment, and several industries like automotive. We have a strong focus on R&D, since this is actually the backbone for our innovative solutions. More than 1,000 people are working in this R&D department, distributed in 21 technology centers all over the world. When I'm talking today about sustainable solutions, just to make clear, this does not mean that we don't have here performance increase or cost efficiency. Actually, our focus is on adding value by increasing the performance plus giving additional sustainability benefits to our customers. But let's talk about concrete. Those who produce concrete elements know their value chain well. It starts from the design and ends in the final recycling after the service life of the element. And actually, Sika is a full range supplier. So for each of these steps in the value chain, we provide solutions. This starts with tools and services in the design phase, software, handbook. Maybe some of you have already downloaded the Sika Concrete Handbook. It's available at sika.com. Just released a new version, by the way. But also in the later steps, several products get applied. I'm not talking in this short presentation about each of them. The most important or most relevant ones I will introduce separately. Of course, most important for the concrete production process. So in particular, the steps here on the right side. Here the admixtures which come into the concrete mix itself are most relevant, and at the same time more concrete admixtures are mentioned here, which are more focusing on the improvement of the service life, of durability, concrete strength, concrete quality and aspect. But let's look further into more details. We all know that we are living in a fast changing world, and a few challenges are ahead of us for the whole society, for the whole construction business, including concrete producers. That is driven by global megatrends and related laws and regulations and additional construction issues. And challenges, especially for concrete producers, are the carbon neutrality, so producing cement or using cement with less CO2 footprint, using alternative binders, using other mechanisms or tools to reduce the clinker content in concrete. At the same time, resource efficiency will be a continuing challenge. Increasing recycling rate is here a key, but also using renewable raw materials and enhancing the service life of concrete. And last but not least, increasing the productivity with automation and digitalization, with prefabrication and modular construction. And for each of these challenges, we have developed solutions. For cement producers, less relevant for concrete producers, but just to let you know, cement producers are using our additives to increase the efficiency of the milling process, but also to improve the quality of the cement. We have developed an admixture technology that allows a very interesting future binder system, so-called LC3, but I will come to this in a minute. PCE technology is a key technology. We believe where many different targets can be met with. And also an interesting recycling process has been just developed by Sika, the so-called recover process, which consumes CO2 during the recycling process of concrete, and the outcome is actually a high quality aggregate, and at the same time also using all components of concrete, so separating the cement paste from the sand and gravel, allowing for up to 100% recycling rate. So what does it mean, carbon neutrality solutions by Sika? To give you a feeling of the dimension, you know, we are adding just a few drops of our chemicals to concrete. We're talking about, in average, maybe only 5 kilograms per cubic meter. But you see, for the cement production, our grinding aids can already contribute with around 20 or more than 20% of CO2 reduction. And together with the benefits that concrete admixture bring, we are ending up at a total potential of 40% CO2 reduction in concrete. Furthermore, concerning resource efficiency, we have tools developed including the Sika code concept. I will come to this in a minute as well. Durability enhancing technologies, water reducing technologies, which allow actually savings of huge amounts of water. To give you a figure, in 2020, the use of our concrete admixtures saved 6 billion liters of water. And we are working on and have already developed bio-based products, so products that are no more based on crude oil, but using renewable raw materials. To the productivity increase, we have tools like the admixtures again. Also here, I will show you examples right after that slide. Digital tools, solutions for modular building. I told you on an earlier slide, with our total precast solutions, we would like to be a one-stop shop for modular building producer. And finally, we are working on 3D concrete printing. We have here a technology developed, a complete system, and whoever is interested in this technology is warmly welcome to get used to it. So some examples of admixtures or products and solutions. The first, and I think the most important one, is the polycarboxylate ether-based superplasticizer technology. Most concrete producers know this and apply such products already. It's I think the most interesting benefit compared to conventional plasticizers is that you can really change the architecture of these polymers and make tailor-made solutions out of it. that has the target to, of course, cost and performance optimize concrete mix designs. So reducing water cement ratio, saving cement, and further benefits. Reducing energy, reducing water consumption, enabling also easier processing techniques like self-compacting concrete, which makes the whole process of concrete production more productive, reduces the operating costs, and increases or improves surface quality, strength, and durability. This technology also allows for slimmer element dimensions in an extreme case using high performance or even ultra high performance concrete, which would not be feasible without PCE technology. And of course, with all these benefits, this technology reduces the environmental impact of the complete concrete. And Sika is proud here to have the first bio-based product on the market. The majority of these products are usually crude oil based, and our our products here are based on agricultural byproducts. PCE technology, together with other admixtures, allows actually the usage of a very interesting and promising future binder system, the so-called LC3 technology. I don't know if you are familiar with this. It's a very challenging approach, reducing the cement clinker by 50% by adding calcined clay and limestone to it. And the challenge was actually that such a concrete produced with such a cement has significantly weaker flow performance or consistency. So it was necessary here to develop admixtures which allow to use such binder for a concrete with similar consistency, workability, early and final strength development as with OPC. So we believe, and not only us believe, that this is an upcoming technology and projected to represent 20 to 30% of all cements by 2050. Another interesting technology important for element production is Sika Rapid hardening accelerators. And I have shown you an example on the right side where you see the temperature curve of a heating of a concrete element. The yellow one is actually the one without the use of Sika Rapid accelerator, and the green one is the one with Sika Rapid accelerator. And you see that it was possible to by increasing the early strength of concrete, reducing the heating period significantly, at the same time reducing the maximum concrete temperature. Very important, you see the concrete temperature here in this dashed line. Very important not to exceed a certain value. Maximum 70% is said to be here a limit. Otherwise, you may run into significant durability problems, cracks, and benefit is energy consumption reduction, of course, productivity increase, shorter cycle times, with that operational cost reduction, clinker reduction. So if the amount of binder or the amount of cement was required to reach a certain early strength, then of course the application of such a system allows for binder reduction. At the same time, durability increase, less OPC is a key reason for the durability increase, but also the mentioned temperature effect, reaching not such a high maximum temperature, and reducing the overall carbon footprint of concrete. Another technology which I don't want to miss introducing to you is the Sika fiber technology. These polypropylene macrofibers can substitute reinforcement. So fibers are already widely used for crack reduction, for increasing the abrasion resistance, but actually these fibers can partially or fully replace also steel, which saves time and money in the construction process, makes it safer and more durable, and increasing also concrete performance. These are easy to handle products and easy to dose, with self-soluble packaging, for example. And we provide here also a design software which allows the calculation from a mesh to the fibers. Another technology which is actually the last one I would like to introduce you in this short presentation is targeting aggregates. You know that the majority of our concrete is made from aggregates. 70%, 75% of concrete and mortar consists of sand and gravel, but actually the aggregate quality has a strong influence on the concrete quality and the applicability. So the challenges will be and are using low quality sands, using new sand resources, sand replacements, recycled aggregates, crushed aggregates, just to mention some. And actually what we provide is here a concept, the so-called Sika code concept, where we analyze the customer challenge, where we have certain tools, including the mix design app, including several special testing tools and services that we provide, and of course a range of products which allow the use of challenging sands. So this is something where we cannot provide just simply a product to a customer, where we offer our service to work out together the solution together with concrete producers. So my time is over, 20 minutes. So before Thomas reminds me, my key takeaway message for you is megatrends like sustainability and digitalization drive the growth in the construction industry. And I hope I could convince you that Sika is here a right partner with its long-term experience, with its focus on innovation, addressing customer challenges, adding value through performance and sustainable solutions, having a full range ready for precast, and being globally active while locally available. Thank you very much for your attention. I hope you found it interesting, and here is my email. Please let me know if you are interested, and we can work out a solution for you. Thank you.
Thank you very much, Markus. Yeah, that was perfect timing. So yeah, there's no questions from the audience, but as you've mentioned there anyway, I was also going to say to our attendees that I'll circulate the contact details of all our presenters today after the event. So if you do have any questions that you think of later, you can get in touch with them directly. So yeah, thank you very much. Thank you, Markus.
Thank you very much. Bye bye, everyone.
So that leaves me to introduce to you our second presenter for today, and that's Edward Birkhead. Edward is the production director at Spiroll. There's Ed. So he's going to talk to you about supporting activities in precast concrete production, including safety, maintenance, and he's going to share with you some best practice tips. So there you go, Ed.
Thank
I
you.
can see your presentation.
Yeah, can you see that okay?
Yeah, that's fine. Thanks, Ed.
Well, yeah, thanks, Tom, and thanks, Carsten, for the introduction. And some of you might recognise me from some of the IPHA conferences, but maybe not for 12 months or so. But no, it's nice to get together, and I'll just move that out of the way. Yeah, nice to get together, and I found these conferences beneficial from our point of view and the sharing of knowledge. So yeah, good morning for most of us, and welcome to my presentation on behalf of Spiroll. Yeah. My name is Ed Birkhead, as Tom said, and I'm the production director at Spiroll Precast Services. Spiroll is a division of the CCL group of companies which have been providing specialised engineered solutions for structures since 1935. We're based in Leeds in the north of the UK, and as some of you will know, Spiroll has been part of the development of the Hollowcore concrete products industry since the early 60s. IPHA's early formulation holds strong links to the Spiroll producers and has developed further ever since. We manufacture Hollowcore extruders, precast manufacturing equipment, and most other ancillary pieces of equipment such as stressing jacks, pumps, barrels, wedges, and grips, all in the factory in Leeds. I look after the production and the product commercial sales for the CCL and Spiroll company, of which we have 31 privately owned subsidiary companies internationally, with currently about 650 employees. These are just a couple of shots from the factory, showing some of the control systems of the extruders, some of the build area there, and a couple of the machines in action. This is a 400mm slab, and we do have a couple of outside plants with the high frequency vibration of the slabs. You get a really heavily compacted slab, which actually stands up well to weather conditions on outdoor plants. This is a recent installation in the Ivory Coast in Africa, which is the first producer in that region. So yeah, so just back to a bit of an introduction on myself. I'm an engineer and graduated from the University of Manchester with a degree in mechanical engineering. I've been with CCL and Spiroll for nearly 9 years, but before my employment, I worked for several years in an automotive manufacturer, and most interestingly in the quality side of production. So my talk today will focus on a failure analysis tool which is ingrained in the automotive industry and is applied to almost every part produced. So this photo just shows an example of some of the turbocharger parts that I was involved with. And in my role currently, I'm personally involved in the volume production of construction products, so wedges and barrels and things. I'm also involved in their certification process and production control from a CE marking perspective, and also other international certifications. But in my experience, none of the construction industry requirements really push the envelope of analysis like some of the other production industries do. So in this presentation, I will simply apply some of the thinking of some of the automotive quality systems to a precast manufacturing situation. I mean, this is also, as part of IPHA, we're all manufacturers to some extent. So this is entirely applicable to not just concrete product manufacturers, but machinery and everything. So I've in my presentation, production support activities are defined as the processes and functions required to produce manufactured goods in a consistent, repeatable and safe manner. So this could be raw material control, equipment maintenance, batching control, and anything which is linked really to the final end product. So most of you, if not all, will have some form of quality management system, and some can be sort of basic and certified to sort of regional standards, and also recognised by other international bodies. There are also requirements from a product-to-product point of view that may be required. But basically, rigorous process and factory production control goes further than the standards and the legal legislative requirements. And the analysis tool I will introduce you to today is called the FMEA. So the FMEA stands for Failure Mode and Effects Analysis. It's a systematic, proactive method of evaluating a process to identify where and how it might fail, and then to assess the relative impact of these different failures in order to identify parts of the process that are most in need of change. So it's quite similar to sort of risk assessment type thinking that some people may be used to, but not just from a health and safety point of view. This is on your sort of production processes. It can also be applied in a design setting as well. So FMEA, Failure Mode Effects and Analysis, is a highly structured, systematic technique for failure analysis. It quantifies the severity, the occurrence and detection likelihood of failures. It is used widely by the military, the aerospace, automotive, tech and food industries. And typically an FMEA is produced for each product or family of similar products. And the FMEA document is best developed by a cross-party group from different departments within the company. So you really get a different sort of aspect from various sort of departments. So an FMEA is developed in a table format, and shown on screen here is an example of an FMEA table, just very simplified. I've personally seen these run to several hundreds of lines for certain products, but this will focus simply on the function of a car tyre as an example. The function being the supporting of the weight of the car, the traction and the comfort. So if you imagine that's what the function we're looking at in the process step. Then the second column has the failure type, in this example a flat tyre. Alternatively, this could be an out of balance tyre, a worn tyre, low pressure, high pressure, wrong specification, and then each of these sort of avenues would have its own developed line of analysis. So after that, you then decide in your cross-party team on the potential impact of the failure and score the severity of this impact. So your score will be given by a predetermined score system. And in the severity column, this could be a score number 10 as a fatality, for instance, down to a number 1 as a failure noticed by, say, less than 10% of the consumer or customer, with all the other scores described between 1 and 10. Then the second column is what is the cause of the failure. Again, there could be multiple scored 1 to 10 on the likelihood of occurrence. This could be between 10 that you pick up the failure every time, or number 1 that it almost never actually occurs. And finally, the detection and the score is how easily the failure is to detect. 10 being basically undetectable, because the higher the score, the more difficult it is to detect, and 1 where the failure is obvious. After you have scored this particular process step, you can combine these by multiplying them together to give you the risk prevention number. Once the process is completed for all the line steps, these risk prevention numbers can then be prioritized into descending order of importance. The manufacturer can then introduce actions to the particularly high risk prevention scores. The manufacturer will then introduce these actions, responsibility and target completion dates for the actions, and can then rescore the failure, severity, occurrence and detection scores with the control actions in place. You can see in this example, the action is to carry a spare tyre and the tools required to change the tyre. So when this is rescored, it brings the overall risk prevention number down to a manageable level. This document then, once formed, acts as a dynamic document that over time will, in very detailed form, describe the processes and controls required to ensure your product is manufactured in a consistent, repeatable and safe manner. So from now, I will apply these to 4 simple best practice examples using the severity, occurrence and detection FMEA thinking. So my first example is barrel and wedge usage and their maintenance. So all Hollowcore and many other precast products use pre-stressed wires or strands in their production. This means that they will be using barrels and wedges to grip that tension. So let's focus on this, on the wire and strand stressing, for instance. The severity of a failure can be extremely high. The rigor and maintenance of the care routines will affect the occurrence, and the detection score is also high because the detection of a potential failure is difficult to detect until the actual failure occurs. The resultant controls are typically but not always applied, are things like, and these are examples that we have seen and also implemented, are things like stressing alarms. So there's an alarm ringing in the factory when stressing is carrying out. We can have strand containment chains up the bed. There'll be also care and inspection training and work instructions for the operators for the products, routine replacement of the equipment by using batch control systems, so you know which are clean and which are in use, and also typical stressing guards and any segregation in the factory and working environment. And we supply many factories with barrels and wedges, and we do see some fantastic processes in place, but also sadly we see some pretty poor ones as well. I mean, the $1 million question is usually, well, how many times can we use these? And we typically say with great processes, you may see, you know, hundreds, 300, 400 uses, but ultimately, if they're really poorly looked after, you could, you know, have a handful of uses. So my second example is looking at calibration of equipment, tracking and its maintenance. So this can apply to anything in the factory, be it the extruders, your stressing equipment, cranes, portable electric items such as grinders, drills, or even fixed installations like your electrical systems or pneumatic systems. And all of these pieces of equipment and systems have failure potentials. Each will vary in severity, likelihood of occurrence, and how easily they are to detect. But the best practice approach, which we have actually implemented in our production environment and even on site operations, is a rigorous asset management system. So we have developed a system through the use of Microsoft SharePoint, and it allows us to allocate a unique identification number to each item or system. We then plan for the maintenance, calibration and servicing, any inspections or testing for each item, and a location and an owner. The system then uses a red, amber and green status tag to easily show if the asset requires attention. We can then plan these activities ahead of time and make sure that they are completed in a timely manner. So from an FMEA point of view, this actually reduces the risk prevention score and shows that controls are working to prevent failures. And again, in factories that we visit, often a lot of these types of processes are not being put into place. My third is looking at raw material inspection and traceability. So, you know, I could ask is, do people have, you know, robust and rigorous incoming goods, inwards and material checks? Because failure of your raw material to meet your specification can have severe effects on the product, which are also likely difficult to detect. And this would be a good use of FMEA to look at each of your raw materials going into the product and analyze what the effect of the failure to meet the required specification would be. This can even go so far as routinely checking quantity as well, which can be difficult for bulk materials. Our best practice advice, and similar to what we've implemented, would be to reduce the risk prevention score, is to have a robust set of simple inspection techniques built into the process. And these could be built into the process using simple specification work instructions that operators could understand. Often material standards can be very complicated and not easily understood by anyone other than the technical staff, who are often not the guys that are actually hands-on dealing with the material. So by employing a simple set of codes, for instance, and we use things like MAT 001, MAT 002, up to I think we've got MAT 054 now in our factory for each of these materials. Our staff can easily check the material certificates supplied with the products and other delivery requirements that we might put. So for strand bundles, we have a direction, a maximum size and weight and things like that. And again, this helps to limit those failures in the process. The final best practice tip, and maybe a slightly different way of thinking about it, is talking about the extruded or slip formed slab profiles, also your strand wastage and production planning. So if you consider the failure of any of the above, this can have a financial impact on the business. Other IPHA presenters have touched on this previously. I seem to remember a presentation by Hollowcore and some of the Alamatic guys, explaining that the proportional cost of product taken up by actual raw concrete material is the highest cost per linear meter. So failure could be in not optimizing your slab profile design. So the failure of this again can be a financial implication. So you could be producing using old technology or poorly maintained machines or wrongly set machines. So the severity here has a high financial impact, and the occurrence is typically quite high that we find. And adding to that, also the detection can be pretty low. There are simple pre-production check sheets that we can supply or sort of work with people to make sure that the machine settings are checked before the production run is started. Another one that we see quite regularly is how much strand is wasted at the end of the production bed. You can introduce a small modification to your abutments to shorten the wasted strand at the end of the bed. And we've done this several times with manufacturers and modified beds and their barrel and wedge setups to reduce this. So even a slight reduction can have a vast effect on the wire or strand usage. If you consider at the moment, strand is at the current market rates, say a kilogram per meter for the sort of larger diameter strands. If you can reduce this by 0.5 meter per strand, and if you use the example of say a 10-strand slab at each end of the bed, this could easily save £5 to £7 per casting process, or it's about $7 to $10. When this starts adding up, there's also taken into account the sort of cost of moving the material and things out of your production facility. So these are the types of thinkings with the FMEA approach that start raising these types of questions. So, I mean, in conclusion, it's been a very sort of whistle-stop quick tour to the FMEA and failure-based thinking, and I hope it has been of interest and maybe even spiked a thought in this area. So if so, then this has been useful. In my experience, in the industry, the construction product manufacturing often lags behind other industries somewhat in their adoption and implementation of these lean process controls. So I hope in the future that the industry may adopt these techniques and learn from the sister industries a bit better. Also, as Tom said earlier, he can share our details after this. So if you have any sort of questions on this is not something specific to Spiroll, but we would happily assist and point you in the right direction. So thank you for listening, and I'll pass you back over to Tom now. Thank you.
Thank you very much, Ed.
Thanks,
no
Tom.
No questions from the audience. And to be fair, you answered the only question I would have had, which was about adoption of things from other industries into the concrete industry. So I think it's a fair point you make there as well. So
thank you.
Thanks very much. Right, that just leaves me to introduce our final presenter for you today, who is Juul van Aar, and Juul is Sales Director for Lifting Solutions at Blij, and he's going to talk to you about various methods and techniques for lifting Hollowcore slabs. So you should be the presenter now, Juul, and there we go. Yeah, we can see the presentation.
Thank you, Tom. Can you see my presentation right now, Tom?
Yes, it's on the split screen mode currently, not the full screen.
One moment. Now it's better, I guess.
Yep, that's it.
Okay. So thank you, Tom, and also thanks to you, Karsten, for this opportunity. Hi all, and welcome to this webinar. I will discuss some various techniques for use for lifting Hollowcores. First, something about our company. Van Blij is a family business with experience for almost 50 years in this market. We're working with 30 colleagues to help our clients in the best possible way. I'm Juul, I'm the sales director of Van Blij, especially for the lifting solutions. We have two departments. We have a department for the cast-in products, and we have a department for the lifting solutions, like the mechanical grabs, like the pallet forks, and like the spreader beams. What Van Blij can offer, we can offer custom-made solutions. We can do engineering, we can do advising. We're producing different lifting solutions, different lifting products. Used for lifting, used for connecting, used for fixing, and especially we're specialists in all different types of materials used in concrete and used in Hollowcores. Except from the in-cast solutions, as I said, we have a lot of lifting materials like the mechanical grabs. We have them for concrete, we have them for Hollowcores, we have them for steel plates, for all the different things you can imagine. And except from that, we're specialized in pallet forks, spreader beams up to 100 ton, or if possible a bit higher. So in terms of lifting, we have a lot of knowledge in-house. The talking points, first I'm going to discuss the mechanical grabs used for Hollowcores. Afterwards, I'm going to tell you something about the in-cast solutions like the lifting loops and the spherical head anchors. Here first you see a mechanical grab used for lifting and mounting on the construction side. And we have them in 3 standard types from 12 ton. The length including the grabs is 14.4 meter. We have the 8 ton and this length is 11.3 meter, including the grabs, and one for 4.2 ton. We provide all these grabs used on the construction site with safety chains. The safety chains are used for lifting in high-risk areas like construction sites. We also have these grabs. These are used for lifting in the factories, and we provide these grabs with rubber pads. And we do that because of the strength of the concrete. When we use the steel pads in this state, then we possibly will destroy the concrete. So for that reason, we will use the rubber pads to lift these Hollowcores. In the next 2 slides, you see 2 different custom-made solutions. This one is for the 2.4 meter width Hollowcores, and the next one is used for the forklift trucks. So we can provide custom-made solutions. Everything that's possible, we can provide. We can make, we can produce, and also we can advise you in what's the best possible way to handle the Hollowcores at which state of the construction. Next, some short video. So you could see how the grab used for mounting and lifting on construction sites is used. Next, mounting and lifting Hollowcores is also possible with cast-in options. As I said before, first we're going to discuss the lifting loops, also sometimes called a figure of 8. The lifting loops are available from 800 kilo per piece till approx 19,000 kilo, 19,000 ton. The advantages of lifting loops are they are very easy to install. You don't need some lifting clutches. You can use normal lifting chains or something like that. The disadvantage is that it's required cutting after that you made the Hollowcore. Next one is the spherical head anchor. Also, the spherical head anchor is very easy to install. It's the most widespread used lifting system for lifting and mounting the Hollowcores. One of the disadvantages also that you need to cut the concrete after producing, and you require a lifting clutch. You can't handle the spherical head anchors without the lifting clutch. Here you see the different positions of the spherical head anchors, one from above and one from the side. And you can also see some caps. The caps are used so the concrete will not spread over the whole channel in the Hollowcore. You see that here in the left corner. So what can we provide? We can provide you from a lot of technical advice and for all these lifting solutions, for the lifting loops, for the spherical head anchors, and also for the different mechanical grabs we can make. We provide all the solutions with all the certifications, with all the documents. We do it within all the CE within the machine directive. So all the documents are delivered with it. And yeah, as I said, we also make a calculation for it, and if necessary, we can also let you see what calculations we made for which lifting solution. So in that case, we can deliver the whole package. We can deliver the product itself, and we can give you technical advice and all the certifications and documents. If you have any questions, please contact me or contact Fred van der Blij. Here you have our contact data. So if you have any questions, yeah, please feel free to ask, mail or call us, and we're always available to help. So that's it. Thank you for listening.
Thank you, Juul. We do have one question from the audience, so I'll relay that to you so you can stay on to answer if that's okay. So I had a question from Patrick Lynn, and he's asked, do you have a lifting boom including clamp up to 20 meters?
Sorry, what did you say, Tom?
So he's asked, do you have a lifting boom including the clamps up to 20 meters?
It's possible to provide that. It's not a standard grab we have, but we can make it for him specially, so that's no problem.
Okay, great. And Patrick also asked, just to reiterate what I mentioned before, he's asked about copies of presentations. So as well as our presenters' contact details, if you're interested in receiving PDF copies of their presentations, those can be provided afterwards as well. And I'll also, alongside the recording of this webinar on the website, I'll also be making some PDFs available to download if they're required. So yeah, thank you very much, Juul, for answering that, and thanks for your presentation. Thank you all again for joining us, and I will just pass over to IPHA's Executive Director Carsten Freeberg to say the final words.
Thank you very much. This was another very successful and interesting IPHA webinar. Thank you very much to Sika and to Spiroll and to Blij for your cooperation during the planning process and for your interesting presentations. And thank you to all who joined the webinar. We plan the next webinar to be on the 7th of May. Participating member companies will be Max Truder from Germany, Concor from the Netherlands, and Solga Diamonds from Spain. We hope that you will all connect again in May, and thank you very much and goodbye from me.